Good evening, one and all. It's very happy to see so many of you here for today's KWK talk. Now I request the Director of JNP, Dr. Guru Prasad, to formally welcome the gathering.
Thanks, Sharanya. My presence here is only contextual, okay? Anyway, respected Dr. Ravi, Professor Ajit, and ladies and gentlemen, I'm really overwhelmed by your response. That shows the attraction of this lecture, okay? So the topic of this lecture, I'm sure that it would be a feast for all of you. And this, all of you know, Kaapi with Kuriosity is a joint program by both ICTS as well as JN Planetarium. And this is yet another lecture under the Kaapi with Kuriosity program. So welcome to all of you once again, and let me welcome Dr. Ravi from Goddard Space Flight Center in Greenbelt, Maryland, United States, who has extensively worked on this subject. And we are graced by Professor Ajit also from ICTS. Normally he will not be here today. We are very glad that he is here. And once again, I welcome both of them as well as all of you. Thank you very much, Sharanya.
I request Professor Ajit to introduce today's speaker.
Good afternoon. It's a great pleasure to introduce today's speaker, Dr. Ravi Kumar Kopparapu, who is a planetary scientist at the Goddard Space Flight Center in the US. Ravi is a world-renowned researcher in the search for exoplanets, in particular the study of its atmospheres, techno-signatures, looking for signs of technology, modern technology in the exoplanets. And his contributions have been quite profound. His planetary classification, the habitable zone classification identification scheme has been a very important one. In particular, it has been used for identifying all the discovered habitable planets that we have found so far. And you will also see that Ravi is an excellent speaker and passionate in scientific outreach, and has done various kinds of scientific outreach efforts, in particular, including science fiction, for example. So Ravi, as a planetary scientist, is a very famous person. You are all here to hear from him because you've heard of him. But perhaps you might not be aware of his dark past. 20 years ago, I used to know Ravi as a gravitational wave astronomer. This was before the actual detection of gravitational waves. And at LSU and Penn State, he used to work on gravitational wave astronomy, in particular, developing a catalog of galaxies to search for electromagnetic counterparts of gravitational wave events, which is still sort of a milestone in the history of gravitational astronomy. Anyway, things have moved ahead. In the last 20 years, astronomy has progressed, both in gravitational waves as well as in the study of exoplanets. We are really seeing big revolutions, and I'm very happy to see an old friend who is pushing the boundaries of really the most profound question ever asked by humanity, which is, are we alone in the universe? So without taking any further time, let me invite Ravi to give this lecture. And as a token of our appreciation, let me hand over a small memento from ICTS.
Thank you, Abhi. Can you all hear me? In the back also, can you all hear me, right? Okay, great. Thank you again. Thank you, Dr. Guru Prasad and Ajit, for having me here. There is a bit of history for me to be here at the planetarium. 20 years ago, I was in the gravitational wave astronomy field. But 30 years ago, when I was in high school, I came here to visit the planetarium with my uncle and my father. And I met a couple of people here and had an interaction. At that time, I don't think this building was there. I think there was an old building still. So when I was coming inside the planetarium, I was like, wait a minute, I know this place before. And then I remembered that, well, this is because I was here before. So it's a really sweet moment for me to be back here and talk to you 30 years later. Never would have imagined that I would be here in the first place. So as Ajit mentioned, I used to work in the field of gravitational wave astronomy. Ajit can tell you more about this. He's a world-renowned expert on that one. I switched fields beyond that, and I always was interested in this kind of work to find aliens, to find another Earth. The reason probably was because I used to watch Star Trek. I know many of you are familiar with this Star Trek series, the old Star Trek, not the new ones. The old, Captain Kirk and Spock and all that, right? So I used to play Captain Kirk, obviously, and I had collected a couple of friends and used to play with that. And my idea was that, there must be alien life out there. And so I didn't realize that eventually I'll come and do this work. And when I was doing this work, it sounded completely like science fiction. So let me assure you that what we are going to discuss here may sound like science fiction, but it is actual science. The science, it's an actual published science by me or my colleagues out there, and something that is so fundamental and so fantastic, it may look unbelievable. And if you have any questions related to that, please let me know, because this kind of work I want to share with everyone, because that's when I see that there is an excitement. I see that there are several of you here attending this talk. It means that there is quite a bit of interest in this, and this kind of science has to reach everyone. And I'll even tell you why we want to look for this kind of topic, why we want to work in this kind of topic. And so maybe we can start with something that's familiar with. Select. Oh, there you go. It's done. It's good. All right. So how many of you know the Voyager spacecrafts? Everybody knows, of course. Everybody knows. All right. And so on February 14, 1990, what's February 14? Valentine's Day. No one can forget. NASA, so Voyager 1 was launched back in 1975. It went through all the outer planetary systems, Jupiter, Saturn, Neptune, and all. Back in 1989, when I was in 8th or 7th grade, they sent many of these Indian magazines published a photo of Neptune taken by Voyager 1. And also there was this program on Doordarshan, Pranav Rai's program, I forgot what it was, on NDTV or something. World this week, that's right, there you go. So he made he had a small documentary kind of thing about Voyager and how Voyager explored the outer parts of the solar system. And in 1990, NASA asked Voyager, when it reached the orbit of Pluto, to turn around and take a picture of the solar system and see how solar system looks like, just like how we want to take a picture of our house if we want to go beyond, if we are just outside of it. There you go. And this is what it saw. So there is this dot, and that dot, and that dot, and that bright light, and that bright point. These are all our solar system planets. And as you can see from that distance, if I didn't write these names over here, every planet would look the same. It's all small bright dots. And this is what we would have looked like for all the planets within our solar system, right? Let's focus on Earth. That's the tiniest dot you are right now. Our entire story history condensed into this tiny dot. No, when you look at it, it's so humbling and it's so humiliating also. Our egos, our wars, there are no borders, there is no boundary. It doesn't show anything, it doesn't care. It shows how humiliating it is for us to think about it. And by the way, this is Earth. We are smaller than this speck on this planet. So we are not even on the scale of this. It's 1 pixel. So we are smaller than a pixel, trying to fight between, to find another small tiny part of the pixel to see if it is mine or yours. Okay? So if this is the world we are trying to find, we want to know what kind of a world it is. There are, that world is active. I'm not talking about other solar system planets, just the focus on Earth because, we are on Earth. And so there are 2 kinds of life according to what I like to classify. There is biological life, signatures of biology, and there is technological life right now on the planet, signatures of technology. Okay, if that's the case, then Earth, as far as I know, is the only planet that has biological life on it. We have no evidence yet of any kind of life beyond Earth, either biological, the only biological. I'll come to the technological part of it. And so if Earth has biological life, then how old do we think is that life on the planet? According to some estimates, it's about 3.8 billion years old at the minimum. And there is some evidence that it's even older, slightly older than that. The whole solar system, the sun itself is about 4.5 billion years. So it didn't take Earth much time to start life on the planet. As soon as the conditions cooled down, Earth started having some sort of life on it. Great. Okay, so there is 3.8 billion years old. Fantastic. How about how old is technological life on Earth? The first evidence of technology that we have is from these stone tools from our primitive ancestors. And that dates back to probably around 2 million years or so. And why do we think that's the case? Because that's where we found these fossilized or even evidence of these tools. There may be evidence of wooden technology well before that. But wood doesn't survive. The wooden technology wouldn't survive all these millions of years of geological evolution. So we may not have that kind of a technology surviving beyond few thousands of years. And so the first technology we ever think was about 2 million years. And then eventually the next technology, that most advanced technology after that probably was the invention of fire. That's a technology we created it, right? Until then, we were just using whatever nature gave us in terms of lightning and then trying to, fire some things up. Eventually, we learned how to create fire. So that's the first technology. And the next, I think, the most important revolution was the invention of the wheel. There is a very interesting history of how the wheel was invented. It was not created as a circular object in the first place. People tried to do different things to find what is the most efficient way to invent a wheel. Okay, so that's the most revolutionary technology later on. And then I think after that comes the Industrial Revolution. That happened around 1800s, 1700s when the steam engine was invented, when the steam processes, when the coal was used to power the industries. And that's the most rapid evolution of technology. And then eventually after that, once the Industrial Revolution started back in the 1800s and 1700s, it was just a matter of time. We just quickly, rapidly rose in creating new technologies in terms of radio technology, internet was a technology, now AI is a technology, right? So we are advancing at a very, very rapid pace compared to the biological evolution of technology, all right? So we will come back to this because it's going to change how we think about it, of finding life on our planets. And so if we have this kind of a planet that has both biology and technology, what do we see when we point a telescope to this planet? This is right now I'm using my eyes to see, oh, there's a tiny blue dot over there. But then if I point a telescope, what do I see? Let me ask you a more deeper question. If it comes out. What kind of a telescope am I using? There are different kinds of telescopes I should be using. All right. Okay. So let's see. If I use a normal visible light, optical telescope, I would probably see something like this. The nighttime Earth shows a different kind of life on Earth. City lights, that's also life. The daytime Earth shows greenery and oceans and everything. That's also life. If you see in infrared, it shows a different kind of life, which is also trees and plants, because they are more reflective in the infrared part of the spectrum, right? And so today's Earth shows active life in all these sorts of things. However, if you use the right technology, there you go. If you our eyes are sensitive to radio frequencies, where let's say you are an alien with radio frequencies, this is how probably the Earth looks like. This is the radio frequency interference of Earth, where you would see very high concentration of radio communications happening at more urban areas, more populated areas, all right? And so if you are an alien having only radio frequency eyes, this is how radio Earth would look like, okay? If these are the different kinds of telescopes we can use, these are the different types of light we will be able to use, how do we find such, like ours, inhabited planets? Inhabited planets. I'm not saying habitable planets. There is a difference. Habitable doesn't mean inhabitants. A planet can be habitable. It can have liquid water, a habitability criteria, but it doesn't have to be inhabited. For example, Mars. Mars, we know, had some water on its surface because we see dried up river beds and all that on the planet. It lost its water way back when. But we don't know if it ever had life on it. Venus, for example, probably had some water on it. We don't know that. But it's super hot right now. So Venus is super hot, Mars is cold, we are in the right place. That's the habitable zone. That's the habitable planet. Okay, so if you want to find this kind of habitable planets, what do we want to do? I'll ask even a more fundamental question. Why do I care? Why is it important to find inhabited planets? Why should we do it? Well, we want to know, if we don't realize how alone we are, because we are all sitting in this room next to each other, having friends and family together, someone to talk to and all. But think all of us as one species, and then try to see if we have anyone else to talk to. That's where we are right now. That's happened to us during the COVID time, right? We had nothing to do. I mean, we had mobile phones. But at this point, we are trying to find out, is our house alone, or we are living in a society with a couple of people around us, and we want to know if there is anyone else out there. Okay? I think we should go ahead and look for them. But how do we know? Where do we look for? Well, first, planets should be around stars. So our galaxy seems to have lots and lots of stars. The bright flash that you just saw over there was the location of the sun in our galaxy. Okay? There are probably about 10,000 crore stars in our galaxy, about 100 billion planets, 100 billion stars. Okay, if there are 100 billion stars, according to our recent analysis, almost every star in our galaxy has a planet around it. And if so, there are 100 billion planets, which means what is the population of the world today? Probably 7 billion or 8 billion, roughly 8 billion people. So if I was to give, I don't know, maybe 10 planets to each person, I think that would be sufficient, right? And still there would be more number of planets left over to give away. And so those many planets are there out in the galaxy. That's amazing. 100 billion planets, I can't even comprehend that number. I can't even comprehend 100, forget billion. All right. So it looks like we found lots of planets, which means we found lots of houses, but there is no one there. The streets are empty, our neighborhoods are empty, our roads are empty, but there is no one there. Why have we not found anyone else yet? Okay, then the question is, okay, you said there are more 100 billion planets, right? What kind of planets did we find? Did we find the kind of planets in our solar system? Then the question is, okay, what kind of planets are there in the solar system? Okay, here you go. Many of you know this, especially the kids know this. The first one, what's the first planet? Only the kids. And the second one. And the fourth one. Oh, I got you there. And the fourth one is Mars, right? And the third one, that's right. So you see there is an arrangement here, small tiny planets in the first arrangement, and then the next larger planets further away from the star, from our sun. Great. Is this what we find out there? Also, you may notice, what is the biggest planet in our solar system? Second biggest one. Third biggest one. Fourth biggest one. What happens after that? Correct. Who said Earth? Raise your hand. There you go. So that's a very important thing to know. You know why? Because of this, if this works. Oh, there you go. So Neptune was the last biggest planet, is the last biggest planet, and then the next biggest planet is Earth. We have nothing in between, right? However, we have found so far 6,000 planets around other stars, confirmed ones, and there are tens and thousands of planets yet to be confirmed. So eventually in the next few years, we will have 20,000, 30,000 planets being discovered, right? And so if our solar system has Neptune, and then immediately after that Earth as the two most planets, we found that most of the planets that we found in our data are planets that are in between sizes of Neptune and Earth, and we don't have any of them. All right? And these planets are called super Earths and mini Neptunes, super Earths, mini Neptunes, right? Because they are in between those two sizes, because they have about those kind of radius. The interesting thing is that we don't have this. It's like everyone else we know has a cousin, but we don't have, which is weird. Like, why don't I have a cousin? I want 3 cousins, 4 cousins, but we don't have them. No idea why. Even I don't know. I don't think anybody knows. Maybe that's how our solar system formed. Maybe that's how our parents are. They just don't want to have too many kids, and maybe that's why we have only 2 planets, the biggest one and the smallest one. But other systems are saying, oh, sure, we can have so many of them. Not only different kinds of planets, we also have different kinds of stars. Many of you know this already, right? The hottest stars are one of the biggest ones, and as you go down, this is our sun, even the coolest ones are the red stars, okay? The red stars are the most common in our galaxy. Sun-like stars are not common in our galaxy. The red cool stars are common in our galaxy. Okay, if you combine all these different kinds of stars and combine all those different kinds of planets and see how common are the habitable worlds in our galaxy, it turns out that there are estimated 200 crore potential habitable planets in our galaxy. 200 crore potential habitable planets. I'll give you an example, okay? Earth right now is habitable. We have life on it. 2 billion years ago, Venus potentially was habitable, probably. So if you were able to time travel 2 billion years ago and looked at the solar system, you would have found that there were 2 habitable planets in our solar system. And if you went 3 billion years before, when Mars also had water on its surface, there would have been 3 habitable planets in our solar system. Who knows which kind of civilizations were there at that time? Who knows what kind of life was there at that time? And so, if our sun can create 3 habitable planets in its history, it is no surprise that there could be at least 200 crore potential habitable planets in the entire galaxy. So our galaxy is probably filled with habitable planets, but we still don't see them. We still don't see it. What's the reason? We'll come to that. Maybe because we have to detect that habitable planet. Maybe we have to detect life. All right, okay, so let's go one step at a time. Do we have the technology to detect biology on any of these 200 crore planets? Okay, that's an interesting question. Okay, then the question is, what kind of life are you looking for? Well, I'm saying water-based life. Why water-based life? Most of our body is water. Why most of our body is water? Good question. Because water is a molecule that can bond easily with many substances. Not only that, What is the most common element in the galaxy or in the universe? Element. Hydrogen, hydrogen, hydrogen. Second most common element, helium. What is the third most common element? Who said that? Fantastic answer. And so what is water made of? There you go. Helium doesn't react with anything. The most abundant element is hydrogen. Third most abundant element is oxygen. You combine them, it becomes water. You make things with the things that are most available. You don't make things that are not available. You have to put extra effort to make things that are not available with, right? And that's why we are mostly made of water. And so if I'm trying to find biology on other planets, I want to find water-based biology, right? And you may ask, oh, what if some life is not water-based? You won't recognize it. Deal with it. We don't have to find everything that the universe is making. The universe has no obligation for you to detect it. It will make it, and it is our need to find life on those planets. And so, universe doesn't care. It'll give everything. We are going to find only a part of the life that the universe is making, which is water-based life. Okay, fine. But how do we find that kind of life? What does life produce? Well, life can produce different kinds of gases. For example, we have carbon dioxide, water, vapor, oxygen, ozone, methane from animal farts, literally. They release methane. And so if you combine all, right now, on our Earth, we have all these gases. And by the way, methane, which is that CH4 you're seeing, methane and oxygen should not exist together. If they are existing together, something is releasing methane into the atmosphere, most likely life. And so if you see methane and oxygen and ozone together, it is a good sign that the planet has life on it, biological life on it. However, there is no reason for us to have oxygen. I'll come to that in a minute. And so if someone says that, oh, I want to find Earth-like planets, I'll say, okay, great. Which Earth do you want to find? Earth was not the same in its history in the last 4 billion years. For example, 3 billion years ago, Earth looked like that, orangish, because it had haze, fog kind of thing, hazy particles. And because it had a different chemical composition, it looked like that, but it had life. Right now, Earth looks like this, a blue planet, and still has life, had oxygen. And so this Earth had only carbon dioxide and methane, no oxygen, still had life. This Earth right now has oxygen, methane, and ozone, has life. So when you ask, okay, I want to find life, which one you are trying to find? We want to find everything. We don't want to rule out everything, right? So, okay. And so even in the history of the Earth, it changed its composition, it changed its color, it changed how it interacted with the atmosphere. And so if we want to do this kind of analysis to find biology, we need to look for all kinds of life because nature is clever, universe is clever. It will not give you what you want. We have to take it what the universe gives us. Okay, so do we have that technology to detect planets, biology on these planets? There are some missions that are undergoing right now. One of them is the James Webb Space Telescope, though it is not designed for searching for life. It is potentially, maybe if we get lucky, we can find it. So the way it tries to find is if a planet goes in front of the star, the atmosphere blocks or the planet blocks the star, and then you can find what kind of chemical fingerprints are there in the atmosphere. There is another mission that's coming up from NASA eventually. It's called Habitable Worlds Observatory. There are 3 mission designs. They have a big mirror. It looks at the star, blocks the star, tries to see the faint light coming from the planet, a habitable planet, and then tries to find if there are any gases that we discussed about on these planets. Okay? Great. Until now, we talked about only biology and biological life. But microbial organisms or birds or animals are not trying to find another life. We are trying to find another life, technological life. And so the question then is, do we have the technology to detect technology on other planets? That's the most interesting thing. Okay, what kind of technology we are trying to find? What kind of technology we can think that we would be able to find? Okay, there are different types. Surface structures. If there is a technological civilization on a planet, it should be probably covered with buildings and roads or whatever structures. Great Wall of China, pyramids, Taj Mahal, whatever. Can we find that kind of surface structures? There are some studies that said probably yes. There are also other kinds of signatures, laser pulses. You know, we want to emit laser pulses and see if we can find those leaked laser pulses. You may ask, who is emitting laser pulses for no reason into space, right? Well, these good laser pulses are a good way of communicating and sending data rates, high efficiency data rates. And so maybe there is a leaked radiation of laser pulses from other civilizations. Maybe we can detect them. We are doing it, NASA is doing it right now, so why not other civilizations, right? So there is a possibility that we can be able to detect it. Radio search for extraterrestrial intelligence. You all know this, radio communications, how they can communicate, we can send signals. Some people are afraid that, oh, don't send signals to space or to other planets, they may come and attack us, Independence Day, whatever, you know, the movies. I think that that's not exactly a right way to think about. If they want to find us, they would build a big telescope and look at us. They don't wait for radio telescopes to do it. They'll just find us. Another one is city lights, night side city lights. If you just look at it, there is a paper by my colleague who published that, yeah, you can find night side city lights on these planets. Any civilization has to use energy, right, to power its civilization. And probably it will have some sort of a city light, mega structures. Maybe some civilizations will build big structures around their star to harness the energy from the star and then use it for whatever they want to do. AI, who knows? Okay, that's one thing we can do. There is another one, pollution. Civilizations can create pollution. Why? Because maybe civilizations pollution comes from fossil fuel, like, you know, our petroleum and whatever. So if they are emitting pollution, can we detect that pollution and see if there is an industrial activity on those planets? And for this kind of finding alien life, they don't have to do anything. They don't have to communicate and tell us, oh, we are polluting our planet. We can just point our telescope and see if they are polluting their planet. They can go on, you know, doing their daily routine. And so during the COVID pandemic, the things were shut down. And so I was going through a couple of websites. That's what you do during the pandemic. And I noticed that the nitrogen dioxide, which is a gas produced by burning fossil fuels, went down at several industrial places on Earth, especially in India and China. You see, this is in between January and April. You can see the decrease in the bright areas are where pollutions were happening. And from this January to April, you'll see that there's a decrease in pollution, which is the nitrogen dioxide pollution. I thought, well, wait a minute. Can we detect this pollution on other planets? If we can detect this. So we actually published a paper. And it turns out that using one of the telescopes that I just mentioned, it is possible to do it. So it is not science fiction anymore. You can actually potentially detect pollution on these planets and find industrial activity on those planets. Not just that, chlorofluorocarbons. Some of you know this. These are these sprays, aerosol sprays, refrigerants. We use it in refrigerants. These are actually made by industries. Nature cannot make them. You have to use industrial processes to make this kind of pollution activity. So if you find this on an exoplanet, then for sure it's a very, very likely scenario that there is an industrial civilization out there. Okay, probes. Maybe the aliens are sending probes to us to see what we are doing. Then you might think, oh, why would they send it? Well, why would we send Voyager probes outside? We are already doing it. Why wouldn't they do it? And the Voyager probe is going away and, you know, to outer parts of the solar system. If we can, and not only that, there was this breakthrough Starshot program. It's probably in suspension now. The original idea was that They want to make a small, tiny camera of this size with a light sail, and shoot laser at it and accelerate that small camera to the 20% the speed of light to go to the nearest star to us, Proxima Centauri, right? And take a picture of it, and then you'll just leave. Do you know how long it takes with our current rocket technology? Let's say Elon Musk builds one of his advanced rocket technology to go to the nearest star, Proxima Centauri. How far is Proxima Centauri? Oh my God, you guys are too good. All right, 4.2 light years. All right, that's great. To go to Proxima Centauri with our most advanced rocket, I think the fastest spacecraft we have right now was New Horizons Pluto mission at one point, or even there is a solar probe. Okay, what's that? Parker Solar Probe, right, sorry. There you go, Parker Solar Probe. How long does it take, do you think, estimated? 6,500 years. Okay, that's a very precise number. That's good. All right, many more guesses. How long does it take with Parker Solar Probe, the fastest spacecraft we have ever built, right? Okay, any other guesses? How long does it take to go to the nearest star? 4.2 light years away. Make a guess. 50,000 years. In comparison to light, these things are very slow. So I'll give you the answer. You are close enough. 72,000 years to go to the nearest star with the most fastest spacecraft we have ever developed. And this one, the Breakthrough Starshot, is planning to, at that time was planning to send with this 20% the speed of light to go to the nearest star in about 30 years. It's a small probe, right? That's good. So if we can think that there is a technology that we can potentially explore, this Breakthrough Starshot was probably scrapped because of technological hurdles right now, or maybe cost estimates, who knows. But at least we can think about how we can do it in the next few years. The aliens have already done that. If we can think right now how to do it and have a potentiality about how it can be done, they may have already done that. They may have already sent probes. We may not be able to detect them, but they may be lurking around in the solar system. Okay, that's great. And it's even probably one of the easiest ways to find life on other planets. You just send a probe and be done with it. Okay, that's not working. Well, there you go. All right, so, but what is needed on a planet to develop technology? Oxygen. Oxygen is needed. Why do we need oxygen for developing technology? We need oxygen to breathe. Why do we need it for technology? Metallurgy. You need to burn things. To burn things, you need oxygen. And you need not just oxygen, you need a certain level of oxygen to burn things. And so until your planet develops an oxygen level to that level, you will not be able to generate technology on the planet. And so if you are finding planets on other planets, you first find out what kind of atmosphere it has. Then you can judge whether that thing has a technology or not. However, a planet doesn't need to have oxygen to have a technology, not to develop a technology. For example, in our solar system, there is only one planet that has biology on it, Earth. But our solar system has many techno-signatures. Guess why? We are sending the probes to other planets. So if you go to some alien comes to Mars and sees that there are several Mars rovers, they'll send, oh my God, I see a lot of alien probes on this planet. There's a technology. If you go around Jupiter or wherever our large planets, we have already sent probes orbiting around them. So our solar system has so much of technology, but only one biological planet. Okay? And so to develop that technology, we need oxygen to burn things, to make things, to weld things, right? Okay, that's a good point. Maybe we need it. Not just that, we need also plants and coal. Why? Because imagine how we did industries. We started industries before that we burned wood to power our civilization. After that, we burned coal to power our civilization. After coal, right now, it still is petroleum. We are burning it. And after petroleum, we are trying to see if we can go to nuclear fusion. You see what's happening here? The more energy density, which is how much energy you can concentrate in the smallest amount of thing, is what we are going for as we advance as a civilization. So if there are other civilizations, they have to go through this. Unless they found something unique that we don't know, a source of fuel. So everyone has to go through this kind of an evolutionary path. Okay, fine. If there are so many billions of habitable planets and so many types of technologies that we just discussed, where are the aliens? Why have we not detected them yet? Any kind of them, not even a hint of it. Okay? And so, let me see. There are a couple of reasons for this that people think. They call it the Fermi paradox. I don't know how many of you know this. It's a paradox means that we should be we think there are so many planets out there, so many aliens out there, but we don't see them. That's the paradox, apparently. Okay, let's see if we can address some of those solutions. Why have we not seen them? Where is everybody? First of all, maybe life is hard. Only our Earth is the best place to have life on this in the universe. Do you believe that answer? I just said 200 crore planets at the minimum in the galaxy. And out of the 200 crore planets, we have only one planet that can develop life on it. I think that's kind of an egomaniacal thing to say that, but probably there might be more of them. We just didn't detect them is the right answer. Fine. Life is probably not hard to arise, but intelligent life is not common. To have intelligent life, again, I said there must be some level of oxygen or some kind of other things happening. So maybe there are all these planets have all small microbial life, but maybe not intelligent life because they didn't have the right conditions or whatever. That's statistically unlikely, in my opinion. Because we have so many billions and billions of planets, there must be, the universe probably is making experiments, and at least some few tens of them have to have some kind of intelligence. Okay? Maybe not all planets have oxygen and plants or coal on them to develop intelligent life or technology. Maybe I have to first do a detection to find it. Oh, there's another one. We cannot recognize advanced technology. We think that, when we see an advanced technology, we will be able to recognize it. What makes you think so? Why should you be able to recognize advanced technology? If you go to Vijayanagara Empire right now, 500 years ago, and showed my laser pointer or my phone and leave it near the fields, some farmer will come and use it for his, he'll think it's a big rock and use it for his purposes. Why should he think he can recognize technology, right? There is another one. There is a limit how far life can advance. It's called the great filter argument. According to this, there is a level where after a certain technological level, life will destroy itself. And so we may not be able to see them because most of the life is gone anyway. But there must be some life out there that probably crossed it already because there are so billions of them, planets out there. Something probably escaped this great filter to come to the point where it can actually contact us. The other one, did not search long enough. Maybe we didn't search long enough. I think I gave this example. Go outside and wait for a bus 2 seconds and come back and say Bangalore doesn't have buses. Of course not. You need to wait longer. Be patient. And that's what we started our agricultural revolution when we started agriculture as humans 10,000 years ago. Pyramids were built 5,000 years ago. Industrial revolution happened 200, 300 years ago. Radio communication started 70 years ago. We actually deliberately started sending signals to space 40 years ago. We started having internet 30 years ago. And you expect to have aliens contact you when the earth is 4 billion years old now just because you stomped your leg and say, I want to find aliens? Okay. The other one, don't interfere. So maybe their aliens are saying that let them develop, let the kids get on, grow up, and then maybe we will be able to come and contact them. Well, okay, there are I'll come back to this number again and again. There are 200 crore planets, And all those planets, let's say they all have life, and they all think that let's not interfere. There must be one rule breaker who'll say, no, I want to touch them. And then they'll try to contact. Is not one rule breaker? Impossible. All right. Hard to travel and communication is expensive. Maybe, like I just said, to go to the nearest star, it takes about 70,000 years. Maybe that's why they don't want to, can't communicate with us. Our communication is expensive. Build big radio telescopes to communicate. But I just said that if we can think about breakthrough star shot that can go to the nearest star in about 20 years, they have already done that. That argument doesn't work. They want to be anonymous. They don't want to contact us for whatever reason. Someone said dark forest hypothesis. I don't know if you know this. They just don't want to contact us. Again, I come to that rule breaker guy. Everybody won't be quiet. One of them will break the rule and say, no, hey, by the way, I'm here. Okay, so where is, even I would like to even have that person, that alien to come and say, I'm here and I'm going to come and destroy you. Oh my God, now I found aliens. Now I can do whatever I want. So even that we can't find. So my favorite hypothesis is this. We cannot recognize technology that is way beyond our capability. Forget way beyond, even few hundred years beyond our technology, we can't do it. How many of you know this movie? I think the old generation knows this movie, not the new ones. It's a good one. This movie is about a Bushman tribe in Africa where they find they find a Coke bottle dropped by a plane pilot from the sky, and then they find it and they have no idea what it is. And so what they do is they use it for softening the bark of a tree, breaking nuts, and so on, without realizing that they have a technology in their hand. And so we are that Bushman right now. We may have already detected life. We may have already detected technology, but we can't even find out. We can't even recognize that kind of a technology. I'm going to leave with this. We recognize only things that are familiar to us. If something unexpected, we may not be able to find it. Kids, find the unexpected thing in here. The O, all right. Oh, you found it? Where did you find? You found it? Yeah, that's where it is. Oops, there you go. Okay, here is another example. What is unusual in this picture? By the way, this is an AI generated image after I gave it a prompt. What is unusual about it? Golden key. Who said that? There you go. Why would there be a golden key in the middle of a busy street? So, what I am trying to say is, you are busy doing other things that you can recognize, while the most obvious thing is lying there quietly for you to discover. All right, next one, same place. Right, why would NASA build a manhole in the middle of an Indian street, right? So, okay, there you go, right there. Okay, and that's the end of my talk. The question of are we alone is not a question if we will find aliens, and I think within our lifetime we will be finding life on other planets. Thank you.
Thank you, Ravi, for this wonderful exposition and taking to this very exciting quest that we have been asking for thousands of years, probably.
Right.
So I'm sure there are many questions. Please raise your hands and we will come one by one. We will give slighter preference to younger audience, but we'll start with you.
Since you know more about NASA, so regarding all these alien things, can you tell us about this Area 52?
Area 52. Okay. All right. So, all these Area 51 and 52, they are all military installations that are happening, have their own, what do you call? It's not any mystery. It's just that it's a military installation that is being protected. So once you protect something and don't release information, people imagine things. If I close my fist and say, I'm not telling you what's in here, then you will imagine many things that's in my fist, right? So there's nothing that we know of that is happening beyond what is there, what is being told to us. If there is, they won't tell us. If there is, they won't tell us. I think the only way to find aliens is through actual scientific investigation, and which I'm sure we will be able to do it at some point pretty soon. So, if it's a military installation, it will be very well guarded and very hard to get information out of it. Yeah. Yes.
So, it's our understanding, I think, that about 2 billion years ago, the amount of oxygen on Earth was about 35% of the atmosphere was oxygen. It has come down to 21% right now. At that time, everything should have been burning, but it wasn't. It went through multiple stages there were those ice ages and whatnot. So are we looking for those kinds of patterns where there is continuous flux of material?
Correct. So his question is about, at some point in our Earth's history, 250 million years ago, oxygen level was very high. What is the oxygen level right now in the Earth's atmosphere? 21%, correct, 21%. At that time, it was 35%. Things were waiting to burn because there's so much oxygen out there at that time. And how do we know? Because of charcoal deposits that they got burned. And so, if the question is whether we can take into account that kind of a...
Whether we look for those kinds of patterns. There should be continuous flux over there. You said that 3 billion years ago there was hardly any oxygen.
Right. So,
is there a relation to life with those kinds of patterns? Life requires that kind of metamorphosis at all.
Right. So life does require, but then that period duration is so small compared to the Earth's history of burning. It is possible to find that level of oxygen on other planets. And so we will be able to use that data point to find signatures of life on other planets as well. We just can't find only oxygen. No single gas is a biosignature. We need to find oxygen with something else, correlation. Otherwise, oxygen can be created without life also. And so if we find that kind of a high amount of oxygen levels, we should see some kind of a low amounts of methane as well or something. Then that combination would be a good signature of life. Yeah. Lots of questions. Hi there. How can I help you?
I had a question. You are saying that, like, hydrogen and oxygen mixed together, it's a good sign, right?
It's water, yes.
Yes. Okay. What will happen if you mix helium with hydrogen and oxygen?
Okay, so helium doesn't react with anything, unfortunately. Yeah, it doesn't react with anything. It's called inert gas. Yeah, it doesn't do much. It doesn't want to be friends with any other element, unfortunately. What can we do? Nothing. It will just stay and say, yeah, I'm cool with you. You, oxygen and hydrogen, go bond together. I'll stay here. That's it. Yeah? Yeah.
How did we figure out that Venus was once had water?
Oh, so we don't know Venus once had water. It's a theory that we think it could have had water at one point. There's also another hypothesis, people proposing that Venus never had water in the first place. Because the measurement of something called deuterium to hydrogen. You know, deuterium is another isotope of hydrogen, right? Yes. So what happens is when, as the sun evolved, it grew in brightness from the last 4 billion years, right? And Venus is the closest planet to the sun compared to the Earth, right? And so when the sun grew in brightness, Venus potentially, if they ever had water, all the water vapor went into the atmosphere. It went into a steam atmosphere. And then when it went to the atmosphere, sun's radiation split hydrogen and oxygen. Hydrogen is a lighter gas, so it escaped. Oxygen came down because it's a heavier gas, right? And so, but deuterium stayed because it's heavier than hydrogen. And so when you measure the ratio of deuterium and hydrogen, you would see that there is a lot of deuterium to hydrogen ratio. And that's how we think that how Venus potentially probably had water at one point.
Yeah. So, thank you for the talk. Yeah. So my question here, I think he's looking here.
Oh, here.
Yeah. So how are we dealing with the fact that whenever we are observing these things, we are looking in the past because they are far away, it takes a lot of time. So when we look at, let's say, sun, it's 8 minutes behind, or we look at Alpha Centauri, it's 4.2 light years behind. So how are we dealing with the fact that it might have changed by the time that the signal has come back?
I'll give you an example. The changes we are so let's say most of the technology we have, telescopes we have right now can look, let's say, up to 100 light years. Okay, 100 light years is, the light takes 100 years to come to us, right? And the kind of signatures, biology signatures I'm talking about takes millions of years. So even if they take 100 years, it doesn't matter whether how much change is out there. We are so insignificant, unfortunately.
Hi, I have a slightly tangent question. So essentially, in your kind of childhood, what made you be interested in astronomy? And the other thing is, second part of it is, as parents, how can we cultivate that kind of interest in our kids? What can we do? What are you doing for your kids to push them in this direction?
Right. So the first question, I got interested in astronomy because Star Trek, I guess. I was watching, and Space City Sigma in 1989 Doordarshan serial. I don't know how many of you know this. You know this? Oh, okay. There are some few videos up there on the YouTube right now, by the way. You might want to look at it. And so what do you do with the parents? How do you encourage students? So first of all, science. Promote scientific thinking every part of the life. Question everything. If you don't get a satisfactory answer, do not compromise. Have that kind of a thinking develop. Okay. And then most important thing about having this kind of a thinking is when you know that what you are thinking is not correct, be open to change yourself. Agreeing that could be wrong, you will be wrong, because we can never be 100% correct, would be the first step to do the scientific thinking in the house. But if you want to pursue this kind of a career, yes, pursue this kind of a career for kids, maths, physics, and chemistry. You have to be really good at it. No question about it. And even if you do engineering, for example, you still can come to science after that, because there are opportunities to do engineering science. Now, in India, we have several institutes. There is ICES, IITs, of course, ICDS is also doing it now. All these institutes are actually having new programs, integrated bachelor's and master's programs. I know some of our students are over here. You can talk to them. They can tell you more about how you can join those programs and do fundamental research. And you can either work here, you can go abroad and come back here again if you really want to do it. I think we have talent. We have so much talent in India. It's just that we just need to get the opportunities and promote that kind of a scientific thinking. Yeah. That's right. In fact, these kind of things are so important. I didn't have this kind of things when I was growing up. If I had this thing, I probably would have been so happy. So thank you for doing this. The really, really important thing you're doing.
You said about when Earth was in its earlier stages that there was no oxygen, but life was still there.
Yeah.
What kind of life was there, and how did it survive?
Good question. It has carbon dioxide and methane. It used those two chemical gases and also sometimes sulfur to make metabolic activity, metabolism in its to generate its to propagate. But then what happened was there was one particular kind of organism called cyanobacteria. We call them the first plants. And so they released oxygen as a byproduct, as a waste. They started polluting the atmosphere with oxygen, polluting. And then eventually oxygen built up to a level that cyanobacteria adapted, but the other organisms died away. And then we are here. So I can't imagine how a life can pollute the planet, right? I mean, we are here polluting the planet, who knows?
I have one more question. You said Mars also had water. I mean, we know all the like evidences that it had water, but how did it lose that water?
How did, who used that water?
Mars.
Lose the water. Sorry, I heard used. Okay. How did, great question, another great question. Okay, the problem with Mars was its size. Mars is about half the size of the Earth. Okay, and when you have half the size of the Earth, every planet, at least our Earth has a dynamo inside. Its core is rotating around some molten material that generates magnetic field. When you have a smaller planet, the core stops, rotating stops, which means the magnetic field stops. Once the magnetic field is stopped, sun's radiation came and just removed water on the Mars. Because of its small size, Mars lost its atmosphere.
Did we check the other planets for water? And how do we prove that Mars and Venus also had water?
Okay, so for Mars and Venus, we already, at least for Mars, we know we have some evidence or dried up rivers already. You know how if you pour water on sand and let it dry, it makes some kind of a dried up shape. That's what we see on Mars. And so we think, and also some chemicals we sampled, we found that there was probably Mars had water on it. Venus is a debatable. We are not sure yet whether it ever had water or not. So we are sending probably some probes. I think ISRO has a Shukran mission coming up at some point. So that's one of the missions where we can see if we study Venus and see if it had water. To answer your question. Did we check with other planets? Yes, we are checking the other planets with our telescopes to see if there is water on it. So far, we have not found any other planet with water on it. We'll let you know.
Yeah. So my question was like during the search of like for the gas, as you said, for the various gases and everything. So if there is some where in a planet there is a high albedo environment like which mimics that atmosphere type. So how do we detect it? And another is, so what is your now we are talking about a universe. What's your belief on a multiverse thing?
Okay, so I'll answer the first one first, which is, I think your question was about false positive. If there is a false positive on a planet, how do you know if it has ever life? Okay, first of all, when we are looking for oxygen and methane and other things, we are now trying to think about what other ways nature can produce gases without biology. And so we know some processes right now how nature can produce it. But there is always a chance that there is going to be a false positive detection for us when we try to find it. We can't escape it unless we actually go there and sample it. Like we can do for our solar system planets, we can send rovers and sample the material. There is always a case. That's why whenever we discover something and tell everyone about it, we say we found a signal of water with this confidence, and that's all we can say about it. And because that confidence can change completely. And the second one is about the multiverse thing. I hope your question was about whether there are multiverses or not. I don't know. Do I believe in it? I'll ask my alternate universe person and I'll contact and let you know. I think it is possible. We will see. There needs to be concrete proof on it. Yeah.
So because of the demand on question time, let me request everyone ask one question, and people who have had a chance to ask one question, maybe we can give a chance to others first and come back. And Ravi will be available over to chat over coffee for some more time also.
Thank you, sir. My question is, as life on Earth is carbon based, is it possible that life on other planets can be silicon based or
right. Silicon-based life comes up quite a bit all the time. Carbon is a good molecule to bond with, several chemicals, and so it's easier. Also, we talked about the most abundant element, hydrogen, helium, oxygen, and the next abundant element is carbon. Why would I go to silicon to do it? And not only that, carbon-based life, carbon can, if it is in the gas form, it can go through circulatory mechanisms and transport information and chemicals. Silicon, if you want to have a gas form, it needs to be in the very high temperatures. And so I can't imagine having a silicon-based life. Maybe there are ways out there, but I think nature prefers what is the most easiest one to go ahead and do it. So carbon-based life is what we are looking for. What's that? Entropy. Yes, always entropy increases as much as, yeah. Life is an entropy machine. So.
Hi. So at one point of your speech, you mentioned that Venus had water earlier than Mars. What makes you say that?
Venus had water earlier than Mars. No, Mars had water earlier than Venus because.
No, but like, what makes you say that?
What makes me say that? Because we can age test the Martian surface and see that Mars had water 3.5 billion years ago, and after that the water went away.
Thank you.
Yeah.
Hello, sir. Yeah, good talk. Thank you very much. So you explored a different world for us. I mean, you showed us very different world. About 200 crore planets is really astonishing. My question is, for example, to explore planets, even stars, there are a lot of missions are there in the international level. And very rarest of so many light years also, they are able to find out here only star is there. And very specifically their altitude, position, able to detect. So in that sense, is there any something like chemical technique where even very smallest planet also we can trace it out what exactly the clues about the life, and any such missions are there at the international level other than NASA? NASA is well known, even other countries also like JAXA, and European agencies. So is there any going on? Just want to know.
Right. So the European Space Agency, European community has a mission in study that it's called LIFE mission. It's an interferometry mission. They are still developing the concept of that. That is one mission that could potentially also do something, find life on other planets. Apart from that, I don't think anyone else is doing it, apart from NASA and that.
There is a proposal from the Indian community, right?
I haven't said that yet because I need to talk to people about it before I say anything.
Yeah, hi sir. First of all, great talk. I really liked it. Apart from that, there was a recent event that excited me a lot around alien life, and world media also covered it a lot. That was 3I Atlas comet that arrived few months before. So I was just was it just a social media fluff or conspiracies, or was NASA also following it with interest?
Yeah, NASA was following it, but it turned out to be a natural object. Yeah. So when I discover a most fundamental discovery like finding alien life, I don't go to social media, I don't go to YouTube and post it. But the President of the United States or the Prime Minister of India will announce it, because it's such a fundamental discovery. So when you see that NASA found alien life or NASA heard sounds from the space or whatever, that's to get views on the social media. If there is such a fundamental discovery, you'll hear it from the scientist or even from the government at some point, because there is no way, if it is coming from this kind of a study, if it is coming from our kind of results, we want people to know that there are aliens. So we do give interviews to social media persons and other media outlets, but we first publish the results. We go through the peer review. We publish results in science journals. Then we tell our agencies. Then they will arrange a press conference. Then where other reporters also come. and then they talk about it. But directly going to social media without publications, without anyone, that is not how science, that's not how, penicillin was sent. That's not how, any other discovery, a single discovery in the human history happened. So alien discovery will also be the same way.
Good evening, sir. Wonderful talk. It was very engaging, and we are more curious now than before. My question is, you mentioned about 200 crores of planets, possible planets to look for, right? Are we just looking at terrestrial planets, or how do we differentiate? Because gaseous planets, for now, we know that cannot hold life. So are those 200 crores we are looking, are all of those terrestrial, or how we?
Yeah, they are all terrestrial planets because we define a size for terrestrial planets about 1.5 Earth radii at the most, 50% more in size than Earth radii. Because beyond that, we think that it accumulates more gas and becomes probably, a Neptune or a Jupiter kind of a planet. And so that's the size we put a limit, 1.5 times the Earth radii as a terrestrial planet. All those 200 crore planets are terrestrial planets.
Okay,
thank
you.
What's your opinion on habitable moons, like moons in our solar system?
Habitable moons, my opinion, I think.
In the solar system.
Okay, so there are, we do have evidence now that our solar system giant planet moons like Enceladus, Europa, and Ganymede and all that, they may have oceans under the surface.
Yeah.
And those oceans may have potentially, we don't know yet, may sustain life. They have some nutrients, they have some water in there. But we just have to send probes and see if they have any life on them. Yeah.
But what do you think is, out of all the moons, which do you think is best for life? That the highest chance there could be?
I don't know unless we actually look for, because we send missions to those kind of planets where we think it's technologically possible to send and look for them. So sometimes it is not which is the best planet, it is sometimes which is the best way to send a probe to. What is the best way to send a probe to, because that's the technology that's possible to us right now. So I know it is not a satisfactory answer, but that's how we do it. So we have to send to those planets where we can only send the probes to. Maybe I'll explain to you later after the talk.
So I have a very naive question. So you are telling about the city lights as a techno signature. So like, how can we detect the city lights from extrasolar planets sitting on Earth?
How do we identify city lights on extrasolar planet? We don't sit on Earth. We use telescopes.
Yeah. Okay.
Right. So we use this telescope in space, the one that I showed, the Habitable Worlds Observatory. That's somewhere out in space. It will, you can look in, we take a spectra. And in the spectral features, you see if there are any emission lines. Those are the sodium lights, by the way. Sodium lights have these emission features. And that's what we try to find.
But that will be very low signatures we'll get.
Only if you have Earth-like light. But if you have a civilization that has a much more coverage of city lights on the planet, not everything has to be Earth-like, right? So what if there is a civilization, the paper discusses that. Let's say you have a civilization that is 10 times urbanization than Earth. Then can you detect it? You can. Looks like you can do it. And so we will cross that eventually in the next 50 years. We will be urbanized in such a way that our nighttime light emission will be increasing quite a bit. We have to. We use energy.
Thank you.
Hello. Hi, sir. It's about differentiating objects.
Can you speak out loud?
Hello?
Yeah.
You can?
Yeah.
So how do we differentiate from a natural object from something that is, we can say, alien, or there was a design behind it? Like if you said the alien object that found was natural, something he asked as question.
3i Atlas.
So how can we differentiate something that we get some object or something floating.
Oh, so
to differentiate something is natural.
Right, right.
But there is an intelligent design.
Right. So before we go to the point of actually saying it is unnatural, listen, there is nothing unnatural in the whole universe. Everything has to follow natural laws. When we say unnatural, it means that it should not exist in nature in the first place. We won't see it. So we could say artificial. So I think the question is probably artificial and natural, right? So before we go to the artificial way of seeing if it is an artificial object or not, we have to eliminate every natural explanation possible. However, if even one natural explanation is sufficient to explain that object, then we don't have to invoke that artificial natureness of that object. In this 3i Atlas case, there were several explanations that can fit a natural way of moving that object. And that's why we think there is a natural, it's a natural phenomenon. And if it turns out that none of the natural phenomena fit it, the acceleration of the object, the movement of the object, the trajectory of the object, the composition of the object, if all of them are not fitting the natural, then it becomes interesting. But unfortunately, it did matter that it can be fit with a natural explanation.
So can we find something like from the shape alone or something like if a chair is there, a chair has to be made because the designs are like...
Right. So
a rock is not like that.
Right. So that's what I'm saying. We have to look for composition. We have to look for how the object is moving. And I will fit all the natural explanations to explain that object. If even one explanation fits that with a natural explanation, then I'll say it is a natural object. We have to make sure that none of the natural explanations will not work for it even if you see a chair, a rock could look like a chair. So I can, because nature has so much time, billions of years to make a chair out of a rock, statistically, randomly also. And so if I find that kind of an object floating in the sky, I need to first find out, not just by looking at shape, I need to find its composition, how it is moving. And if I can figure it out, if it's a rock, I also can do that, then I'll prefer that explanation than an artificial explanation.
Hi, great talk. My question is that, so biology is unstable, right? Unstable in the sense always changing, evolving.
Yeah.
So we were not the same we were earlier. So series of two questions actually. So the first thing is life might occur and then go away. It kind of destroyed itself for whatever reason, like cyanobacterium, it caused an extinction event, right? And the second, so because of that, the stable thing on the other hand is technological progress. Maybe the machines that we are building now will continue to exist forever. So shouldn't we be looking for AI stuff? So all of whatever you said may not hold, right? We're looking for the wrong thing, looking for the wrong signature, you think?
Okay, should we look for AI technology?
Because the civilization that created it is gone. It is for whatever reason, it's turned into something else, or even our own civilization, if we come back after say 500,000 years, we may not be in the same shape or form, we may not exist. So are we looking for the wrong things? So should we be looking for these non-carbon based technological signatures?
So there is no wrong thing to look for because we don't know what the right thing is to look for. Because we don't know how anything looks like in the first place. And so if we give an example, the technological civilization in the lifetime of human history is only 2 million years. That too, the communicative technology is only 60 years old. Whereas the oxygen lifetime is 2 billion years. And so if we are looking for life, then we might be looking for this kind of gases. And so in terms of AI technology, but going forward, Earth can, in the next billion years, Earth could potentially have a technological civilization that is much, much more dominant than these biosignature gases. Potentially, it could happen. And so we are indeed looking for that. However, how do you even look for a technology that is billion years old? Or even with AI, it will be even beyond AI. Or even, once AI takes over, it can potentially create a technology that is totally unrecognizable to us. Like the inattentional blindness I'm saying. It can create a technology that even if it is in front of us, we won't be able to recognize it. We can't even recognize in what happened, in the last 100 years or 200 years. In the next 500 years, I can't even imagine what technology would be. 100 years ago, there was no internet thinking at all. So I don't know what technology I can think about to detect it. So I'll think about the technologies that we have right now, and can we detect this technology is the only thing I can potentially do right now.
The follow-up to that,
Yeah.
right, very quickly. So what is your take on the dark forest hypothesis? So basically the deal is that,
yes,
if you look at any civilizational contact in our Earth,
yes,
the superior culture has pretty much devastated the inferior culture. I'm not using those words as placeholders.
Yeah.
No subjective value to them. And they use them like cattle, more or less. Like,
yes.
So we are going looking for this, right? So it's logical that if we discover a civilization, we should attack first.
Okay. Okay. So I'm trying to now to reduce my anxiety here because I have so many thoughts about it. The dark forest hypothesis. Some of you probably know this. How many of you know about the three-body problem? Science fiction series. All of you. Okay, fine. All right. So the three-body problem book series has this dark forest as one of the book names, I believe. One of the sequels. It's the idea here is that none of the civilizations are contacting us or in contact with each other because they are afraid that other civilizations will destroy them, so everybody lives quietly. That's one of my things that I mentioned over there. That is a great idea to sell a book. But I don't think it is a great idea to actually scientifically make sense. Because again, if there are that tells us that that kind of argument lacks the data about how many billions of planets are out there. There must be at least one who will break the rule. Not everyone will be quiet, and not everyone will be at the same stage of evolution. Some will be so advanced, some will be less advanced. So the advanced one, they don't even care about what is happening about dark forest or light forest or whatever it is. So they may not, that kind of a hypothesis does not, in my opinion, it doesn't make any sense because that, as I said, there must be one civilization at least that will not follow it. And then there's no need to communicate. They will find us. If they want to find us, if they are so advanced, they'll find us. And so if they want to destroy, we would not be talking here right now. And so that is a good book. The characterization of that book series is atrocious. However, the stories are really good, but I think that's the only way that got more attention because of the book series. Otherwise, I don't believe in it.
Okay, last three questions. This here, yeah.
Hi, sir. My question is about what is the dark matter and dark energy, because it covered maximum area in the universe.
What if the dark matter and dark energy covered most of the stuff in the universe?
Means it's present in the universe, but we can't.
I couldn't hear properly. Can you speak out loud?
People say means dark energy and dark matter are most of the areas covered in the universe.
Yes.
But we can't detect it.
Well, we can infer where dark energy and dark matter are based on what kind of observations are available from our astronomical observations. So we know how much dark matter is there, and we know how much dark energy is there.
Maybe one.
We can't detect. We don't know what they are made of. You mean? Okay. Right. So we are trying to find that. We don't know about it right now, but we may know in the future when we actually make observations, right? So. Second last, go ahead.
Yeah, so you were already talking about that we can't detect a technology which we don't know. So just a follow up on that is like you mentioned a lot of ideas which are related to how human life has grown. Are there some ideas to detect these planets which are like completely out of the box and might not be something which we have gone through as living organisms?
Yes, they could have all these planets. Many of these planets may go through a different evolutionary state completely and may have an early life in the first place. and have a very late evolution of technology. So for example, some planets may evolve a technology after 6 billion years, whereas we evolve technology after 4 billion years. And so definitely they may have.
Are there some interesting ideas which people are pursuing? I'm just asking as a.
Oh yeah, definitely.
Can
In
you
fact,
share some?
yeah. So they, so some of the things that they potentially want to do is how when oxygen can actually start over. Evolution of oxygen. It started 2.7 billion years ago. It started out and then increased to a maximum level. And that may not be the case in other planets. In fact, technology can happen multiple times, just like evolution, life advanced multiple times. There were 5 mass extinctions on Earth. And so life evolved again and again and again. So there is a theory that technology probably happened again and again and again. Here is a question. What makes us think that dinosaurs didn't have technology? If they had a wooden technology, dinosaurs existed for 300 million years. We just existed for the last 10,000 years in the technology. If dinosaurs already developed a bow and arrow kind of wooden technology, how do we know? How do we know they were not intelligent? Velociraptors were intelligent to coordinate and attack. How do we know they didn't have intelligence? How do we measure intelligence in the fossil record? We can recognize only technology. We can't recognize intelligence. Technology is a manifestation of intelligence. No, yeah, it could be. That's the great filter argument. So if they ever developed a technology that is wooden-based, bow and arrow, they may have disintegrated already, and we think they are not intelligent at all, and they were, Jurassic Park and whatever. So.
Okay, Rafi gets the last question from the audience, then we'll take one from the online.
Okay. Hello? Yeah, so you said that if everyone doesn't want to do it, then one person will break the rule. But what if that one person also can't break the rule or can't say anything because
then we are stuck in finding aliens forever. Again, that's what I'm saying. We don't have any reason to expect to detect alien life. It is our need.
And also if how do you communicate directly to someone? Say if some alien wants to say something directly to Earth, then how will they say that? Because maybe by the time it comes, we might have moved or something.
We will be here, but they may be, if they were 100 light years away, we might be receiving the signal. If they are using radio communication, we might be receiving signal 100 years later than, when they were there, if they were 100 light years away.
But then won't we move it by 100 years somewhere?
Move from where?
I don't just move, the Earth might move somewhere.
Earth is just going around the sun. So if we are here 100 years later, maybe we will be there, but still the radio waves will come and reach.
Sun is also moving.
Sun is also moving, not in the 100 years. Sun moves around the galaxy in 250 million year orbit. In 100 years, it will probably move this much.
Okay.
Spatial expansion, that's also very slow. The spatial expansion is, you mean the Hubble constant spatial expansion? Oh, that's like giga years, billions of years. So that's nothing. I mean, we are expanding right now, but we don't detect it, right? So, what if there is coming more than 100 years? We won't, our current technology you mean the radio waves communication? They can come from 1,000 years away, but still, the sun doesn't move that much in the galaxy in the 1,000 years. The scale is huge. I mean, we think everything 1,000 years is too much, but our galaxy thinks in terms of billions of years. And so it's like a small thing.
Now we'll take one question from our online audience. How does the presence of water becomes crucial for life to exist? Can we explore other liquids as a medium for molecule to interact and become complex molecule till it become living cells? If so, what would be the characteristics we would be looking in that liquid?
Okay, so that's a great question. So Titan, Saturn's moon, has hydrocarbon lakes, not water-based lakes. So probably like how our early Earth had at that time. And so that we are sending probes. It's called Dragonfly probe to Titan, to explore if there is any hydrocarbon life, potential life on Titan. So there is a possibility to have such kind of a non-water-based life. What was the other question? That's the
characteristics of yeah.
Why water?
No, if we find such a liquid, what will be the characteristic?
Ooh, that's a good biology question that I would not probably be able to answer, because you need to think about life cycle and metabolic activity for that organism as well. Like, how do you use hydrocarbon and then use metabolic activity? What do you produce? That's a biology question. Maybe possible to have that kind of life.
Okay, I think this is a good time to break. I know there are many more burning questions, but we will be available for at least a few more minutes over coffee. You can chat with him. So let's thank Ravi for this wonderful talk and this patient answering of all the burning questions from the entire audience. Let me also remind you that this is a part of a monthly series of public lectures organized by ICTS and the Planetarium, called the Kaapi with Kuriosity. And there will be many other exciting topics with many other very interesting lecturers. So if you would like to get updates from ICTS, please sign up for the mailing list on the ICTS webpage, as well as follow up on our various social media. Please keep in touch, and hope to see you again in the next month. So with this word, let's thank Ravi once again. And please join us for coffee outside. Thank you.